US has maintained a moratorium on underground system nuclear testing since the 1990s. And we need to make sure that should the US ever need to use one of these devices, that they are secure and ready for the president. I'm Dr. Sarah Nelson. I'm with the National Nuclear Security Administration, part of the Department of Energy. I am currently Deputy Director for the Office of Experimental Sciences within the Office of Defense Programs, which takes care of our nation's nuclear stockpile. I am in the management of research, coordinating with our partner national labs, such as Livermore, Los Alamos, Sandia, the Nevada Test Site, and others. The scientific basis of stockpile stewardship, it was one of the first parts of the National Nuclear Security Administration upon the cessation of testing, and the need to ensure that these devices would work, to make sure that the constituents that make up these devices are still functioning as appropriate or close to original condition. It's not only experimental science, but a lot of modeling and simulation as well. The conduct of nuclear security and deterrence-related research is really exciting. You can work as an individual contributor on small projects. You can work as part of a huge interdisciplinary team. There's everything from the folks running the shots for the National Ignition Facility, the engineers, there's modeling and simulation, there's understanding and quantification of uncertainties, which is really important. There's a lot of little measurements that need to come together to really give you an understanding. There's materials properties studies under extremes, because these are extreme conditions with a device detonation. These aren't normal, benchtop kind of experimental conditions, which is one of the reasons we have these complex HEDP facilities. There's really quite a lot to explore there, and some really great frontier physics. In my career, I've had the pleasure of discovering not only one isotope during grad school, but 14 total, including one new element as a postdoc. It's part of a huge collaborative team. It is really something special knowing that you have made something new that's probably never been seen on Earth. Is really, really hard to make. I mean, these experiments take sometimes weeks to create single atoms that then immediately decay or nearly immediately decay. And you're working with these incredibly large, like accelerator facilities. Being able to do that and to find that real needle in a haystack is gratifying, it's exciting, it's pushing our understanding of the periodic table, periodic properties. It's just really fascinating to think about from a scientific perspective. I would say to students who are exploring a field of study, it's really important to know what you don't want to do, almost as much as it is to know what you do want to do. There's an area of science that is going to keep you up at night wondering about the universe, how are you going to solve them, or working with others to solve that big problem. Then that's something that you might really want to look at, something that's really got to grab your attention and keep you interested.